Hello and assalamu alaikum. The topic for today's lecture is chords inside a circle. In this lecture, we are going to be going through two theorems. But before that, we need to go through the definitions which will be used to learn the theorems. So let us start. The first definition is, what do we mean by a chord? So a chord is a line segment that joins or connects any 2 points on the circumference or the boundary of the circle. So if you look at the figure drawn below, if you look at these points, point A and point B, both of them, they are connected by a straight line, and both A and B, they are at the boundary of the circle. So this AB is known as a chord. Similarly, XY, point X and point Y, both are at the boundary, so this is also a chord. It's similarly CD. The second definition is definition of a perpendicular bisector. So perpendicular, I hope you know this, that perpendicular means at right angle, 90-degree angle. And bisector means two equal parts. Bisect means to divide into two equal parts. So uh, if a line AB bisects, this means divide into two equal parts, another line CD at right angle, then AB is said to be perpendicular bisector of the line CD. Since this line AB is at right angle to CD, so AB is perpendicular to CD. And since this line AB, line segment basically, it bisects CD, then this now is known as AB is a perpendicular bisector of CD. Let us proceed to theorem 1 now. This theorem is stated in different ways in different texts. I've tried to narrate all the possible ways. So the first one is perpendicular bisector of the chord passes through the center of the circle. This means if you look at the figure, if you have got this, I call this point as x. If OX is perpendicular bisector, then it will pass through this point O, which is basically the center of your circle. Then the next one is, if a line segment from the center of the circle to the chord is perpendicular to the chord, then it will bisect the chord. This means if you draw a line which is at right angle to the chord, then it will divide the chord into two equal parts. Your chord will be bisected. Similarly, the third one is exactly opposite statement of that, that if there is a line segment from the center of the circle which bisects the chord, then it will be perpendicular to the chord. So boys, before I proceed on, I need to tell you one important fact that will be used when we will be solving questions, and that is, if you connect this point C, which is on the circumference, to this point O, which is at the center, then this new line that is there, this is known as radius of the circle. This new line is basically the radius of the circle, and so you've got a right angle triangle now, and you can use Pythagoras theorem if you need to find any length. Let us proceed to a sample question. Uh, this is the circle, and you can see AB is a chord inside the circle, and this is the line segment which is perpendicular to the chord AB. So by theorem 1, if any line segment is perpendicular to any chord, then it will surely bisect the chord. So this length x, if it bisects means divide into two equal parts. Then if this half of this chord is x, then the other half must also be x. So now if you look at this triangle, you basically have got two identical triangles. This length is 10. OA is the radius. Similarly, OB is also radius. If this is 20, this is also 20. So you can use any one of these triangles to find the length of x using Pythagoras theorem. So let's use Pythagoras theorem. I hope every one of you know that. Pythagoras theorem says that 20 square, the hypotenuse square, equals to sum of square of other two sides. That equals 10 squared plus x squared. So let's do a bit of calculation and then subtract 10 square from both sides. So this becomes 20 square minus 10 square equals, from here 10 square will be eliminated. Either you shift 10 square to this side and subtract it, or you subtract 10 square from both sides. So this equals to x squared. Now let's use a calculator to do a bit of calculation. So 20 squared minus 10 squared equals, so that is 300. So 300 equals x squared. Now you need to find the value of x, not x squared. So you need to take square root on both sides. So square root of 300 equals square root of x squared. So this square and square root goes away. So what about root of 300? Let's use calculator for that. So root of 300 equals 17.3. So this is the solution. This is the value of x. And if you need to find the length of the chord AB, you need to multiply 17.3 by 2 to find the length of the chord. Let us now proceed to theorem number 2. Theorem number 2 states that if two chords they're equal, then they are equidistant. Equidistant, this word means equal distance. So if you've got, if in a circle, if two chords are equal, then they have same distance from the center. So their perpendicular distance stays the same as it's given in the figure. Or if two chords are equidistant from center, then they're equal. So they are opposite statements or converses of each other. So this statement number 2 is converse of statement 1. So the statement 1 is if AB and CD, they are two equal chords, then x equals to y. And the converse statement is if x equals to y, then AB equals CD. So it can go both ways. So let us proceed to a few questions on theorem number 2. So the first question, if you look at the question, there are two chords AB and DE. And if you look at the figure, this distance of the first chord AB from the center, which is CM, this is 3, and this the other distance of chord DE from the center, that is also 3. So whenever two chords they are at equal distance from the center, then chords they are equal. So AB and DE they are equal. Now since AB and DE are equal, so therefore half of each chord will also be same. So this 4 centimeter is basically half of AB. This 4 centimeter is like this till here. So this DF will be 4 and FE will also be 4. So your DF is basically equals to AC. That was equal to 4 centimeter. Now if you need to find DE, that will be basically two times of DF. So 2 times of 4 is 8. So this is the first question. So we have used converse statement of theorem number 2, that if two chords they are at the same distance from the center, then chords they're equal. And if chords are equal, then half of them is also same, and twice of 4 is 8. So 8 centimeter is my final answer. So let's proceed to the second question. This is a more tricky question. If you look here, so here AB and CD, it is given that they are equal chords. So this means if these chords are equal, then their distance from center should be same. So um, you need to find EM here, and no figure is drawn here on this side. So since chords are equal, since AB equals to CD, this means your EM must be equal to FM. This distance from center should be same. These two distances should be same. Why? Because these chords are equal. Whenever chords are equal, they are equidistant from the center. So can you find this? Yes, we can. Let's call this side to be X. So DF is 8 centimeter, and this is basically half of this chord DC. And since this angle is 90, so this DF and FC, they must be equal. So this is also 8 centimeter by theorem 1. So now we can use Pythagoras theorem here to find this value of x, which is basically your fm. So let's use Pythagoras theorem. It says that 10 squared equals x squared plus 8 squared. So subtract 8 squared from both sides, or simply shift this 8 squared to this side and subtract it here. So 10 squared minus 8 squared equals x squared. I have removed this, move it to this side. So now 10 squared minus 8 squared, let's use calculator for that. 10 squared minus 8 squared equals 36. So 36 equals x squared. Now take square root on both sides. So square root of 36 is 6, your x equals 6. So if your x is 6, this means this EM must be 6. So EM equals 6 centimeter. Thank you very much for watching the video.